That's when we use our calculator. If it does not say round to the thousand, then we do not use our calculator. All right, so we have inverse sine and inverse cosine, and we're going to do inverse tangent today also. So the notation for that is either a little -1, and then there's always going to be some, it's the side right here, so it's going to be some number, or arc sine of a side, okay? Cosine is going to be either inverse cosine of some number, which would be the side. We're talking about SOHCAHTOA. Sine of an angle equals opposite over hypotenuse. That opposite over hypotenuse was the sides. If we're doing the inverse, it's the opposite. Or we could say arc cosine of a side. Either one of those mean the same thing. Okay, just the notation. Either one of those notations means the exact same thing. All right, so in Unit 1, we did the sine of 30 degrees. So we looked at our unit circle, we went to 30 degrees, we looked at the y value, and it was equal to 1/2. Now, we take the inverse sine of the side, the 1/2, and that's going to be 30 degrees. So you can see how that notation works. Cosine of 30 degrees. Unit 1, same thing. We went to 30 degrees, we looked at cosine. It was √3 over 2. Now, if we take the inverse cosine of √3 over 2, that's going to be 30 degrees. So you take the sine cosine tangent of an angle, and that gives us a side. You take the inverse of a side, and that's going to give you an angle. Now, if you remember Unit 2, we just did that, took a test yesterday. We had some restrictions in order to make the equations functions. That's going to carry over into Unit 3 when we are evaluating, and it's called principal value. When you find the principal value, you have to realize there are restrictions. Because if I go back here and I think of inverse sine of 1/2, well, there are two places on the unit circle where y is equal to 1/2. 30 degrees is not the only answer. But we have these principal values. Because look, if I looked here, y is also equal to 1/2 there, so it should be 150 degrees also. But we went back to those restrictions from Unit 2. We have to only think about the quadrants where that particular function or equation would be a function, and it's called principal value. Your calculator, there's not like some special mode where you put in principal value. Your calculator's automatically in principal value. The book, it expects principal value. You don't have to worry about that. On our homework right here, your assignment, it tells you on your syllabus exactly what to do. So always follow the directions off your syllabus, because sometimes the book doesn't give you as specific directions as we need. All right, so principal values of inverse sine. So going back to Unit 1, inverse sine went from, Unit 2, -π/2 to π/2. We restricted the domain from -π/2 to π/2, which takes us to quadrants 1 and 4. So if we're finding the inverse sine, we can only look in quadrants 1 and 4. This says don't enter quadrant 3. So we can't enter quadrant 3. We can't go from 1 to 3 to 4. We either have to go from 0 up or 0 down. Those are our two options. We cannot go into or through quadrant 3 when we're finding principal value. That does not take quadrant 3 off the unit circle for life. Only principal value. We can still find the sine of 210 degrees. The sine of 210 degrees is still equal to -1/2. That's not principal value. That's Unit 1. So you got to be careful to know what you're doing Unit 1 or 2 or 3, what the question is asking, because unit 1 is going to keep popping up over and over again. All right, inverse cosine. Inverse cosine, we started at 0 and we went to pi. So those were our restrictions to make the inverse cosine a function. So that takes us to 1 and 2. We didn't graph inverse tangent, so we just have to know inverse tangent's going to model inverse sine, so that's going to be in 1 and 4. If we were to have graphed it, those would have been the restrictions. The reason we have 2 quadrants, because we have to have a positive and a negative possibility. If we're talking about the sine is positive up here, y is negative down here. Cosine, x is positive, x is negative. Tangent, y over x is positive, y over x is negative. So we have to have a positive and a negative quadrant. But we have those restrictions. You have to know and memorize those restrictions. If you don't know those restrictions, then it's going to be hard to get a lot of things right. Also very important that you do not go into or through quadrant 3. So if I'm looking at my unit circle, 7 pi over 4 is not even a possible answer for this unit at all. Okay? These 11 pi over 6, 7 pi over 4, 5 pi over 3, 3 pi over 2, not even possible answers. We have to use negative pi over 6, negative pi over 4, negative pi over 3, and negative pi over 2. Because we cannot go into or through quadrant 3. The only way to get to 4 is to go in a negative direction, clockwise. All right, so another thing to remember, while we do not make you rationalize in pre-cal, we always tell you have to know what something rationalized is. It doesn't matter if your final answer is rationalized or not. It has to be simplified. Simplified and rationalized, not the same thing. 2 over 2 simplifies to 1. 2 over root 2 is fine. You don't have to do anything with that. But root 2 over 2 is the same as 1 over root 2. Unrationalized, rationalized. So root 3 over 3 would be the same as 1 over root 3. The reason you need to know that is because you'll see it both ways. You don't know which way you're going to see it. So while you don't have to rationalize an answer, you have to recognize whether something is rationalized or not. You have to know the difference. And you learned how to rationalize in Algebra 2. You had to rationalize every single answer in Algebra 2. Now you just don't, but you have to still know how to do it and what it looks like. So those are very important to know because they're going to come up a lot. You never know which way it's going to be written, given to you. So you have to know that they're the same. All right, we're finding the exact principal value. Means we're not putting this in a calculator. Do not go home and say, oh, I didn't know that I couldn't use my calculator. Yes, you did. The notes, we don't use our calculator. When it says round to the thousandth, we use our calculator. That's how we know the difference. We don't just get to use our calculator all the time. In radians, so it told us it wants our answer in radians, so we have to follow those directions. None of your answers should have a degree symbol. There's going to be no degrees we write at all. And then it says if it is defined. Well, something that would not be defined. One thing, a 0 in the denominator, that would be something undefined. But we're given the ratio, so that's not really going to pop up. Or we could say the hypotenuse is bigger than, is smaller. Hypotenuse is smaller than a side because we're still dealing with right triangles. We haven't changed. Still, everything's a right triangle that we do. So if something happens to not be on the unit circle and we have to draw a triangle in the particular quadrant and our hypotenuse is smaller than a side, that's another way we know that something could not be defined, which is not the same as no solution. No solution would mean there's an equal sign, there's an x, we're solving for a variable, we are not solving for any variables, okay? I'm going to put some equal signs here, but we're not solving, so no solution is not even an appropriate answer. All right, now, these do not require any work. I'm going to show a lot of work so you can see what I do, but they do not require work. The first thing I do on these is I draw myself a little X and Y axis, and I mark out all the quadrants that don't work. So sine, I have to know my restrictions. So I know my restrictions. I can only be in quadrants 1 or 4. Those are the only possibilities. Because of the page we just wrote down. You got to know them. I've memorized them, so I'm good. Now your turn. 1/2. Where is the y? So we want to know where is y equal to 1/2. Well, it can't be in quadrant 4 because those are negative values, so we want to look in quadrant 1. Where is y equal to 1/2? So we go to our unit circle, we look at quadrant 1, we look at the y value, and there it is. Answer in radians, so your answer is pi over 6. Pi over 6 is your answer. Work is not required. There's no work that you have to do. Remember what you're doing here, it's the inverse sine of y equals theta. The sine of theta equals y. Unit 1, sine of an angle equals the y value when we're on our unit circle. If we're not on our unit circle, that's when you use our SOHCAHTOA, opposite over hypotenuse. So the inverse of the side equals the angle, the sine of the angle equals the y. So we're looking for where is y equal to 1/2. That's all we're doing, looking right at our unit circle. All right, inverse cosine can be in 1 or 2. Cosine is the x, so positive, negative, so 2's out. So we got to look in quadrant 1, so we're looking for where is x equal to 2. We go to our unit circle, x is not equal to anywhere. That does not mean not defined. Maybe, but maybe not. We can't just go straight to undefined. What that means is we have to draw a triangle in quadrant 2. And so we have our theta right here, because this equals theta. So remember, cosine of theta equals 2 over 1. We're not on our unit circle, so that's adjacent over hypotenuse. Hypotenuse is smaller than a side. That's one of those situations where it's not defined, because if we say adjacent hypotenuse, that's not a possibility. So undefined. UND, not defined, undefined, do not write no solution. There's not even an answer that makes sense. It did not say solve anything. It said evaluate. There was no equal signs given. I put an equal sign, but that wasn't given in the problem, just to rewrite it something. It tells you if it's defined. It's not defined, UND is fine with me. Just because it's not on the unit circle does not mean it's undefined. Could be. You got to draw your triangle. You might be able to create a triangle. Maybe not. Just depends on the problem. All right, tangent. Inverse tangent can be in 1 or 4. X and y are positive. X is positive, y is negative. So we're only concerned with quadrant 4. All right, so inverse tangent of our side, which is y over x, equals our angle. So we're looking for where is y over x equal to -1. That's what we're doing right there. So we go to our unit circle. We're looking in quadrant 4 only. That's all we care about. Y divided by x, that's not going to be 1. Y divided by x, that's not going to be -1. But here we have the exact same numbers. One's positive, one's negative. The exact same thing divided by the exact same thing is 1. One's positive, one negative. There's our answer. Not 7 pi over 4. 7 pi over 4 makes us go through quadrant 3, and we can't. So negative pi over 4 would be our only answer. There are not multiple answers. There is one answer only. Do not tell me it's -45 degrees. That does not follow the directions. Don't give me it's negative pi over 4 or 7 pi over 4. That is not correct. 7 pi over 4 goes through quadrant 3. We cannot go through quadrant 3 when we are doing inverses. Quadrant 3 still exists. It hasn't gone away for just regular trig, but inverse trig, quadrant 3 is off limits. All right, inverse tangent of root 3 over 3. Inverse tangent can be in 1 or 4. Positive tells us that is in quadrant 1. So quadrant 1 is all we're concerned with. Remember, this is inverse tangent. We have root 3's on our unit circle, so this is probably a unit circle problem. Y over x equals the angle we're looking for. So really we're looking for where is y divided by x equal to root 3 over 3, which is also the same as 1 over root 3. Big, huge slide a second ago. Said those were equal. One's rationalized, one's unrationalized. So you have to recognize that those are the same. Root 3 over 3 equals 1 over root 3. 1 over root 3 is not rationalized. Root 3 over 3 is rationalized. So either one of those would be the same. So we go to our unit circle. Remember, we're only concerned with quadrant 1. Well, our only possibilities are this and this. Those are the only two possibilities because we cannot get a root 3 from a root 2. We cannot get a root 3 from a 1 or a 0. So we're dealing with tangent, which is y over x. Y, we can't divide fractions, multiply by the reciprocal. Those 2's cancel. We get 1 over root 3. There's our answer. We just found it. Up here, I'm going to go ahead and do this. Root y over x just gives us root 3. 2 divided by 2 is 1. We wanted 1 over root 3. Again, if we rationalize that, that's the same as root 3 over 3. So our answer would be pi over 6. You will start to do these so much, some of you will just know where 1 over root 3 is, or root 3 over 3, or where root 3 is. You'll start to just figure it out, and you can do that in your head. If you can't do it in your head, write it down like I just did. Y divided by x. Can't have complex fractions. Ever, ever, ever. No complex fractions. That means a fraction in a fraction or a decimal in a fraction. All right, cosine can be in 1 or 2. I'm coming up with that just off that page of the notes where it said what are the restrictions. It's negative, so 1 is now off limits. So I'm in quadrant 2. I'm looking for where is x equal to negative 1/2. So I go to my unit circle, I look at the x values. There's x equals negative 1/2, 2 pi over 3. No work is required on these. You can look at your unit circle and pull your answers off. If you want to show work, I'm showing you some work, how to get to the answer, so you're not just writing numbers down and you're not knowing where I'm getting them. If you need to show that, show that. Show as much as you need to. All right, inverse sine of negative 1. So inverse sine can be in 1 or 4. Negative, so that y is negative down in quadrant 4. So we're looking for in quadrant 4, where is y equal to negative 1? Remember, we cannot go through quadrant 3, so we have to go here and down. So we look for where is y equal to negative 1? 3 pi over 2. But 3 pi over 2 would require us to go through quadrant 3, so the answer has to be negative pi over 2. Negative pi over 2. That is the only answer. There are not multiple answers on these. No multiple answers. One answer only. Do not tell me it's this or this. It is not this or this. It is one answer. There are lots of things with multiple answers. This is not one of them. Only one possible answer. All right, the next ones are kind of double problems. Notice you have an inverse on the outside and a regular on the inside. You could never have two inverses here or two non-inverses. It has to be one or the other. You can't take the inverse of an inverse. You can't take the sine of a sine. It's not a thing. It's not possible. You have to work from the inside out. So cosine of negative pi over 6, that's just a unit 1 problem. We go to our unit circle. We go to negative pi over 6. Here's negative pi over 6 right here. And we look at the cosine value, which is the sine, x value, net root 3 over 2. So this is equal to root 3 over 2. So now we replace that. Now we have a new problem, the inverse sine of root 3 over 2. So we're done. We're done with the first line. Now we have this problem just like number 1 through 6. We're inverse, so we're back to restrictions. Restrictions. Inverse sine can be in 1 or 2. Because it's positive, we're looking for where is y equal to root 3 over 2 in quadrant 1. So unit circle. Where's y equal to root 3 over 2? And that's going to be at pi over 3. So this would require a little bit of work. Like I would expect to see this written somewhere. Root 3 over 2. If you have root 3 over 2 written somewhere, replaced it, that'd be some points. And then inverse sine of root 3 over 2, the answer. So this step right here, this right here would be the work I would expect to see, and then the answer. There would not just be credit. The answer only doesn't show me how you got that answer. All right, now this is the opposite. This one, the inverse was on the outside. Now the inverse is on the inside. So this is going to be different steps to get the answer. So now unit 3 is on the inside and unit 1 is on the outside. So where does y equal 1/5? Well, hopefully we know that is not on unit circle. If it is not on the unit circle, that does not mean it's not defined. It means we have to draw a triangle in the correct quadrant. So inverse sine can either be in 1 or 4. Because it's positive, that takes us to 1. So we draw a triangle, and there's our angle. This is going to equal some angle. So we can say the sine of some angle equals 1/5. If it's helpful to write it that way, some people like to write that out, some people don't. It's up to you. You don't have to write that. But if it's helpful so you know what you're doing, you can. The inverse of a side equals the angle. The sine of an angle equals the side. Because we're not on the unit circle, this is our opposite over hypotenuse now. Because we're not on the unit circle. We're somewhere. I mean, we could draw that 1/5 if we look. Here's 1/2, so we know 1/5 is going to be somewhere down here. We just don't know exactly where it is. So that's why we have to draw a triangle. And the sine of an angle equals opposite over hypotenuse. So the sine of that angle in quadrant 1, opposite over hypotenuse. So really what we did is we found our angle. We want the tangent of some angle. We just don't know what it is. We know it's that right there. And the tangent of an angle is opposite over adjacent when we're not on our unit circle. So the tangent of that angle that we created is opposite over adjacent. So now we just have to find adjacent. Pythagorean theorem, right triangle. 1 squared plus something squared equals 5 squared. X squared equals 24. So x equals plus or minus, when we take the square root, 2 root 6. Again, depending on what quadrant we're in is going to depend on whether it's positive or negative. Because we're right here in quadrant 1, we went to the right, that's positive. Up is positive. If we're in quadrant 4, that y value be negative. Quadrant 2, negative, positive. So we're going to use the positive 2 root 6 right here. And so now we have our answer. Opposite over adjacent. If you want to rationalize, you can. Multiply by root 6, multiply by root 6, and you get root 6 over 12. You do not have to rationalize, but if you want to, you can. It is not necessary. That is not more simplified, it is rationalized. Simplifying 2 over 2 equals 1. That you have to do every time. This you don't have to do. 1 over 2 root 6 is fine, because if you rationalize incorrectly, you went from a right answer to a wrong answer. No need to rationalize unless you want to. Some people just can't handle that radical in the denominator, and that's fine. All right, one more like that. 2 sine of pi over 3. That's back to unit 1. 2 times the sine of pi over 3. Next 2 means multiply. So the sine of pi over 3, unit circle, pi over 3, root 3 over 2. Root 3 over 2. Simplify, so we get this is root 3. And that's going to equal some angle. So we could write the tangent of some angle equals root 3 if we want. Really what we're looking for is where is y over x, because there's a root 3 on a unit circle, so probably on the unit circle. If we do a triangle, you draw a triangle, figure out that way if you want. Where is y over x equal to root 3? Well, we already did that work earlier. Only options are going to be at pi over 6 or pi over 3. When we did pi over 6, we got 1 over root 3 or root 3 over 3. When we did at pi over 3, we got root 3, so there's your answer. At pi over 3, y divided by x is equal to root 3. So that would be pi over 3 would be your answer. Again, I would expect to see this right here. This would be the work I would expect to see right there. That you found that 2 times sine of pi over 3 is equal to root 3. Now, if you had left it 2 root 3 over 2, that is not the final answer, so it wouldn't matter if you simplified or not, okay? I wouldn't be grading your work whether you simplified or not. Simplified is the final answer. So if you wrote inverse tangent of 2 root 3 over 2, that's okay. And then you found your answer off the unit circle, that works too. But your final answer is the one that always needs to be simplified. Questions on non-calc parts? All right, calculator, pretty simple with these because these buttons are on our calculator. One thing you have to be careful you do is read the directions. Do not skip over directions. Some of you skip over directions and then you get them wrong. And then you get mad because you just had to read a simple direction. Be sure you read the directions. Use the calculator, round to the thousandths. If you were more than 1/1000th off, it is wrong. 1/1000th is a rounding error. More than 1/1000th, you round to the 10th, wrong. You round to the 100th, wrong. 1/1000th is -1. Anything more than that is incorrect. Doesn't matter, like it, not like it, that is how it is, okay? So then it says answer in radians. So we just have to make sure our calculator's in radians. You have to be told because this equals some angle. This is the inverse tangent of some side equals some angle. It told us to answer in radians. So what that means is our calculator just needs to be in radian mode. Test or quiz, we clear it. So it's automatically in radian mode. So we have the inverse tangent, so second tan of negative 2.9. Enter. There's your answer. Negative 1.239. Negative 1.239. The 7 determines whether the 8 moves up or stays the same. Inverse sine of 0.75. So second sine 0.75. Be sure you type this in correctly, in the calculator correctly, because just one little thing wrong makes it all right or all wrong. There's no points on this. It's either it's right or it's wrong. 0.848. Okay, 0.848, rounding to the thousandths always. Unless it's money, a fox, something like that, you truncate. Money you round to the hundredth. Everything else is thousandths. And then inverse cosine of 0.058, so second cosine, 0.058, enter. 1.513. 1.513. The 7 moves the 2 up. It does not matter what is after that. The fourth number only. You don't look at the fifth to move the fourth, to move the third, to move the second. You only look at the fourth, and that determines whether the third goes up or stays the same. That is rounding to the thousandths. All right, so that is inverse sine, cosine, and tangent.